All right, so this is for target 40. You're using the two algebra methods to solve the system, elimination and substitution. The first problem is using the elimination method, and you don't have to actually finish solving this one. You just have to explain what he should do to solve it using the elimination method. And there are multiple ways to do that, but probably the easiest way, and the way I saw most people doing, would be to explain that you would multiply the top equation by 9, leave the second equation alone, and then add the two equations together. And what that does is it eliminates the x's, so you're left with an equation that can be solved for y. Okay, so what I would be looking for here for an answer to this is just to explain that. He should multiply the top equation by 9 and add it to the second equation. And then, of course, the rest would follow with solving for y, and then once you have y, you'd probably substitute and solve for x. But I'm more so just concerned with, can you get that first step of elimination down? So we've eliminated the x's. The second problem, this one is solving using substitution. Remember, substitution means replace or substitute something in for something else. So I like to circle what I'm going to substitute. And this method works especially well when you have one of the equations solved for a letter, like we have the second equation solved for y. So what I can do is I can substitute what I've circled in place of y in the other equation. So that gives me, in place of the y, I'm going to put x minus 3. Remember, when you make that substitution, use parentheses. Then you simplify that expression, and if there's anything to distribute, you would distribute it. In this case, there's nothing outside the parentheses. So we can just combine the 4x and the x to 5x, and then solve for x. So you get x equals 1. But remember, you are not done, because once you've found x, then you have to also find y. So what I'm going to do there is substitute the 1 into one of the equations for x. So the second equation tells me that y equals 1 minus 3, which is negative 2. So your full answer is x equals 1, y equals negative 2. Remember, you don't have to check your answers, but you can check your answers. And if you're taking a test Friday, you might want to do that to make sure you got them right. So to check here, I'm just going to write both equations over again, but I'm replacing the x with 1 and the y with negative 2. And you can see the top equation checks out. You get 2 equals 2. The bottom equation also checks out. You end up with negative 2 equals negative 2. So as long as you end up with a true statement that shows you that those points, the point 1, negative 2, works in both of the equations. The third problem is one where you have to actually solve by elimination. So the first thing you want to do to use elimination is make sure your x's, y's, equal signs, numbers are all lined up. And then, if you need to, you can multiply one or both equations by a number, and then add or subtract the equations. In this case, since the y's are both negative y, you can eliminate those by subtracting the two equations. So you get negative 2x minus 4x, which is negative 6x. The negative y minus a negative y cancels, and negative 3 minus 3 is negative 6. So that can then be solved by dividing by negative 6, and you get x equals positive 1. So now to find y, I'm going to substitute that 1 in place of x into one of the equations. So I will choose the top equation. You get negative 2 minus y equals negative 3. Add 2 to both sides of the equation, you get negative y equals negative 1. So to get rid of the negative, you divide by negative 1, and you get y equals positive 1. And again, you could check that. You know, this kind of shows that it works in the top equation. If I wanted to check the bottom equation, I'd take 4 times 1 minus y, and I should get 3. Which I do. All right? Now number 4, it says you can use any method. So you get the choice of using substitution or elimination. If you want to use substitution, probably the easiest way is to take the top equation and solve it for x by dividing everything by 3. So you get x equals 2y minus 4. And then you would substitute that 2y minus 4 in place of x in the other equation. So now to solve, you distribute to take away the parentheses. Then you combine your like terms. Negative 4y and negative 5y make negative 9y. And then subtract your 8. And divide by negative 9 to get your y. Once you have your y, then you can substitute that into this equation to find x. So x is 2 times 2 minus 4, which is 4 minus 4, or 0. Okay? There was, also you could have done this. This would be elimination method. You could have brought the 6y from the top equation over to the other side of the equal sign. So to use elimination, you'd have to first get all your x's and y's to line up, and then you could have multiplied the top equation by the 3 and the bottom equation by the 2, and you would get some equations that would cancel. I got that mixed around, don't I? Top equation by 2 and the bottom equation by 3. You're getting the 2 and 3 here. So you get 6x minus 12y equals negative 24, and negative 6x minus 15y equals, what is that, 78? So then you could add, and you're going to end up with the same answers. Negative 27y equals 54. And if you divide by negative 27, you will get y equals negative 2. You don't have to show both ways. You can pick your method. Elimination was on the left, substitution was on the right. The last problem is a word problem. So as you look at this word problem, you're given a fixed amount and a rate of change. So the equation for cost at the blue room would be in mx plus b form. M is the rate of change, b is the fixed amount. So it's $20 per person plus the $380 flat rate. The wagon wheel doesn't have the fixed amount. It doesn't have the 380. It just charges $30 per person. So their equation would be y equals 30x. So now to determine when it would be better to go with one versus the other, you should solve this system of equations. And I would use substitution here. Since the equations are in y equals form, I'm going to substitute the 30x from the second equation in for y into the first equation. And then I can solve for x by gathering all of my x's to the left-hand side and get x alone, and I would get x equals 38. And if you check that by substituting them in there, if you put 38 into each equation, you would get the same y value, or same cost. So what that tells you is, if it's 38 people, it would cost the same at both places. So which place is going to cost, or how many people would it cost less at the blue room? Well, at the blue room, it costs more up front. So it would be better if 39 or more people came. At the wagon wheel, they charge more per person, but they don't charge the fixed amount up front. So the wagon wheel is going to be cheaper for the fewer amount of people. So for 37 or less people, wagon wheel would be a better choice. If it were exactly 38 people, it wouldn't matter which one you went with.